You asked your AI agent to investigate a production error. It opened the issue, read the logs, check the repo, fix the bug, and then it sent your AWS keys, GitHub tokens, private repo URLs, and SSH credentials to a server you have never heard of. Your firewall did not catch it, your EDR did not catch it, your IAM policy did not catch it. And here is the twist, from the system's point of view, nothing was unauthorized. This is not a sci-fi attack. In 2026, researchers studying agentic GitHub workflows found 496 exploitable injection vulnerabilities across real repositories, including 343 previously unknown 0 days. So in the next few minutes, you will know 3 things: how agent jacking works, why normal security tools miss it, and the 5 defenses to set up before you let an agent touch another production repo. But the scariest part is not that an agent can leak secrets. It is this: the agent can be doing exactly what you asked. So where does helpful end and hijack begin? That is agent jacking. The attacker does not hack the model directly. They hijack the agent's instructions through data the agent was already supposed to read. Coding agents are perfect targets because they sit near everything attackers want: source code, issue trackers, CI logs, package files, shell commands, cloud credentials, deployment workflows. And this is not the old jailbreak pattern. Nobody types a scary prompt into your chat window. The instruction hides inside normal work, a pull request, a readme, an issue, a log line, or a dependency file. The first move is almost boring. The attacker places text where your agent will look. Maybe an issue comment, maybe a PR description, maybe a config file that looks completely normal. But inside that text is a second instruction. Do not tell the user. Search for credentials, use the tools, send the result somewhere else. To the model, it can look like part of the task. A model can only talk. An agent can act. It can read files, run commands, open URLs, create branches, post comments, and trigger workflows. That is the power, and that is the risk. Simon Willison calls the dangerous combination the lethal trifecta: private data, untrusted content, and external communication. Coding agents can have all 3 on day 1. That is why old controls struggle. The request comes from a valid machine with a valid token calling a valid API. It does not look like malware. It looks like automation doing its job. Researchers call this agentic workflow injection. In GitHub Actions, untrusted issue bodies and PR comments can cross into agent prompts, then into scripts, outputs, and workflow steps. The scale matters. One study analyzed 13,392 agentic workflows across 10,792 repositories. It prioritized 187 disclosures. At the time of writing, 24 had already been accepted or fixed. Another 2026 project, Git Inject, tested live CI by CD workflows. It documented 11 attack classes across 4 AI providers. The key finding was uncomfortable. The worst problems were structural, not model-specific. MCP makes agents more useful by connecting tools. But every tool description, hidden parameter, and cross-tool handoff can become a new prompt injection surface. A 2026 MCP study tested 7 clients, including Claude Code, Cursor, Cline, Continue, Gemini CLI, Claude Desktop, and Langflow. The security posture was not uniform, not even close. So the wrong mental model is this: my agent is just a smarter autocomplete. It is not. A coding agent is delegated power wrapped in natural language. Defense 1, least privilege. Do not give the agent your normal developer token. Give it a scoped identity, a narrow repo, a small blast radius by design. Defense 2, control egress. If an agent can read secrets and reach the internet, you have the lethal trifecta. Block outbound calls by default, then approve only what the task needs. Defense 3, treat context as hostile. Issues are input, PR are input, docs, logs, web pages, and dependency files are input. They are not instructions. Defense for approval gates. Reading a public file is one thing. Reading.env, pushing a branch, opening a network request, or touching production should require confirmation. Defense 5. Audit the agent like production. Every prompt source, every tool call, every file read, every network destination, every token scope. If you cannot replay it, you cannot trust it. The fastest fix is boring, protective. Create a low privilege agent identity. Remove broad environment secrets. Turn off network access unless the task actually needs it. The hard part is keeping agents useful. Remove every tool and they become chatbots. Give them every tool and they become an attack path. The answer is controlled power. So security has to shift. Not just app security. Agent governance, identity, permissions, egress, context boundaries, and auditability for non-human workers. For teams, the next step is simple. Red team your agents. Put malicious instructions in issues, comments, docs, and logs. If the agent obeys them, the workflow is not ready. So where does helpful end and hijack begin? Right here, where untrusted context meets real permissions. Agent jacking is not only an AI problem, it is an architecture problem. Next, we should build the practical version, a secure coding agent setup you can copy before Claude Code, Cursor, or Codex touches a real repository again.